The moon is close. That is the lie your brain tells you. It looks like a thing you could almost get to if you just had a better plane and a free weekend. In reality, even the nearest major object in space already breaks normal human scale. So Earth is our starting point, not as a symbol, just as the last place where distance still feels honest. Here, kilometers mean something. Hours mean something. You can drive across a country, fly across an ocean, point at a map and more or less understand the cost. Then you leave Earth, and that system starts failing almost immediately. That's the rule of this video. The bigger the scale gets, the less your usual units help. First, kilometers work. Then they get stupid. Then even astronomical units stop being enough. Then light itself becomes a measuring stick, and even that won't save your intuition. We're going step by step. Earth, the moon, the rest of near space, then the solar system, then the gap between stars, then the galaxy, then groups of galaxies, then structures so large they stop feeling like places at all, and after that, the edge of what we can observe. Same universe, different rules every few stops. And the ugly part is this. Space does not become hard to understand somewhere far away. It becomes hard almost right away. We don't need to start with another galaxy to break your sense of scale. The moon is enough. Start with the moon. It is the closest thing up there that people treat like it's basically next door. It isn't. The average distance is 384,400 kilometers. That already kills normal intuition. Put it in human terms once, just to break the habit. If you drove there at 100 kilometers per hour, non-stop, with no sleep and no stopping, it would take more than 160 days. For the nearest major object in space. So the problem shows up early. Space does not become absurd later, it starts that way. And then the scale jumps again. The sun is not just farther, it forces a different unit. Earth is about 150 million kilometers from the sun on average. That distance is called 1 astronomical unit, 1 AU. Because once numbers get that large, repeating raw kilometers starts to become useless. The number is still true, it just stops meaning anything to a human brain. This is where two worlds split apart. Human transport works in one regime, light works in another. Light moves at about 300,000 kilometers per second, not per hour, per second. At that speed, sunlight reaches Earth in about 8 minutes 20 seconds. So the thing warming your face is already more than 8 minutes old by the time it gets here. That sounds manageable, almost small, but only because light is doing the job. Everything feels close when light is carrying the message. Nothing feels close when matter has to make the trip. That is the first real change in scale. Not just bigger numbers, a different way of thinking. If you use human speed, even the moon is annoying. If you use light, the sun looks almost local. Same space, same distance problem, completely different result. And this is still the easy part. We are not even leaving the immediate neighborhood yet. We are still inside the tiny area where people say things like nearby with a straight face. So people say Mars like it's the obvious next stop. Close, familiar, basically next door. Not really. Mars is not one distance away. It moves. We move. The gap changes all the time. At the closest, Mars can be about 54.6 million kilometers from Earth. At the far end, it can be about 401 million kilometers away. That is not a rounding error. That is the difference between a hard trip and a stupid one. This is the part people flatten. Space is not a straight road with a fixed sign that says Mars. You do not just point the ship and go. The planets keep moving while you are trying to reach them, so timing matters almost as much as speed. Miss the window, and the trip gets longer, slower, and more expensive. Wait for the geometry to line up, and it is still bad. Just less bad. Even the phrase, travel to Mars, hides the problem. Which Mars? The one 54.6 million kilometers away, or the one 401 million kilometers away? Those are very different engineering problems pretending to be the same sentence. Conditions do not stay polite either. Fuel plans change. Communication delay changes. Energy needs change. Return options change. The target keeps drifting through space like it has somewhere else to be. Because it does. If you want one quick human comparison, fine. Even at airplane speed, you are not talking about a long flight. You are talking about something absurd. So the usual travel instincts are useless here. That is the point. Mars is inside our own neighborhood, inner solar system, the place people treat as manageable. And even here, the problem is already messy, moving, and unforgiving. So when somebody jumps from that to casual talk about visiting other stars, you can stop taking the sentence seriously. If Mars is this inconvenient, interstellar talk is not bold. It is mostly people skipping the math. And Mars is still close compared to what comes next. So let's keep going. Past Earth, past Mars, past the part people still pretend is nearby. Neptune sits about 4.5 billion kilometers from the Sun. That number is too big to feel real, so use light. Light from the Sun needs about 4 hours and 15 minutes to reach Neptune. Not a probe, not a rocket, light. The fastest thing we know. And even that needs most of an afternoon. This is still the same solar system. Not deep space, not another star, just our local setup. Now put a human object into that scale. Voyager 1 launched in 1977. It has been moving outward for decades, and right now it is more than 22 billion kilometers from Earth. That makes it the most distant human-made object ever sent out. A useful fact, not because it proves how powerful we are, because it shows the limit. This is the farthest piece of us. After all this time, after all that speed, it is still being measured in billions of kilometers, inside the Sun's wider neighborhood. That is the part people skip. They hear 22 billion, and their brain gives up. It sounds final. It isn't. It just sounds expensive. And it gets worse. In 1990, Voyager 1 turned its camera back. From about 6 billion kilometers away, it took the photo now called pale blue dot. And the reason that image matters is simple. It is not poetry. It is scale. Earth in that picture is not a world. It is not a continent map. It is not even a clear sphere. It is a tiny bright speck buried in scattered light, easy to miss if someone doesn't point at it. That is what 6 billion kilometers does. It reduces every border, war, city, religion, career plan, family argument, and airport delay into one pixel-sized inconvenience. Actually less than a pixel. People like to make that image emotional. It doesn't need help. The photo already does the job. It is direct visual proof that Earth is small in a way normal language cannot explain. You can argue with numbers. You can't really argue with the picture. And this is still not the big scale. That's the annoying part. Neptune is not the edge. Voyager 1 is not the edge. Even that famous photo was taken from a distance that is huge to us and still not remotely close to the end of the Sun's reach. So now the unit has to change again, because kilometers are about to become useless in a new way. So where does the solar system end? Bad question usually, because people want one clean line. There isn't one. One boundary is the heliopause. That's where the solar wind finally gets pushed back by the interstellar medium. The Sun stops blowing outward hard enough. Space outside starts winning. That matters, but it is not the whole ending. Because the Sun does more than throw particles around, it also holds things with gravity, and gravity reaches much farther than the solar wind ever did. That brings us to the Oort Cloud. Not a neat ring, not a wall, more like a huge sphere of icy objects spread ridiculously far out around the Sun. This is still part of the Sun's domain, still its loose outer territory. Still not true, we're done now space, in the simple way people want. And this is where the numbers stop being cute. The Oort Cloud may extend out to 100,000 AU. That is about 1.9 light-years. Read that again, light-years. Not because someone wants to sound dramatic, because AU starts to fail out there. Everything we talked about before this, Earth, Mars, Neptune, Voyager, all of it was still deep inside the Sun's area of influence. Even the far stuff was local. Just local on a scale that already humiliates the human brain. So no, the edge of the solar system is not one thing. There is the edge of the solar wind, then there is the much larger reach of the Sun's gravity. People mix these together because one ending feels cleaner. Reality usually refuses to help. And once your map has to include distances like 1.9 light-years just to describe the Sun's outer junk drawer, AU is no longer enough. The unit changes because the situation changes. Not cosmetically, physically. Now we can leave the Sun's neighborhood for real, and the numbers get worse. So now we leave the planetary part. Not mentally, numerically. The nearest star system to the Sun is Alpha Centauri. Not some remote target at the edge of a map, the nearest one, closest available. and it is still about 41.3 trillion kilometers away. That is around 276,000 AU, or 4.4 light-years. At this point, the old scale is dead. Inside the solar system, huge numbers were still usable. Ugly, but usable. Here, they stop meaning anything. You can say trillion kilometers. Your brain still hears far. It does not hear what the number actually means. So use something human. Use a machine. Use the fastest, farthest thing we actually threw out there and did not lose immediately. Voyager 1. Voyager moves at about 17 kilometers per second. That sounds fast because it is fast by human standards. Faster than bullets. Faster than anything that matters in daily life. And it is useless for this job. At that speed, getting to Alpha Centauri would take more than 70,000 years. Not a long mission, not a hard mission, a time span longer than recorded civilization. When Voyager launched, Disco was still alive. If it were aimed at Alpha Centauri, it still would not be doing the job. It would just be drifting through a timeline nobody can manage. That is the real point. Voyager 1 is usually treated like proof that humanity reaches deep space. Fair enough. It is also proof of the opposite. It shows the limit. The farthest human object is not even beginning to solve the interstellar problem. It only makes the problem visible. This is the contrast people keep dodging. Planets are one category, stars are another. Crossing planetary space is difficult. Crossing interstellar space with current human technology is basically a different problem. The scale resets the whole conversation. So when people talk casually about going to another star, they are usually skipping the part where our best real hardware turns 4.4 light-years into more than 70 millennia. That is not a transportation system. That is an admission. And Alpha Centauri is the nearest case, the easy one, which gets worse when you stop looking at nearby stars and start looking at the structure they sit inside. Now take that whole solar system and drop it into the Milky Way. It barely registers. Our galaxy is about 100,000 light-years across, not kilometers, not AU, light-years. And inside that span there are hundreds of billions of stars, not a few bright dots, a full population, more systems than a human brain can hold in any honest way. So where are we in that? Still basically at home. People like to imagine humanity as something that has already spread outward. It hasn't, not in any serious sense. The cleanest proof is the radio bubble. For roughly 100 years, Earth has been leaking radio and TV signals into space. That means there is now a sphere, about 100 light-years in radius from our earliest broadcasts, where those signals have had time to reach. That sounds big until you put it next to the galaxy. 100 light-years against 100,000 light-years. That is not expansion. That is a stain. And even that needs a warning label. This does not mean we control a 100 light-year region. It does not mean we occupied it. It does not even mean every point inside it can clearly detect us. Signals weaken. They mix with noise. Some may be too faint to matter unless someone is looking carefully with the right tools at the right frequencies. So this bubble is not human territory. It is just the rough zone where signs of us could, in principle, have arrived and maybe be noticed. That is the real scale of our presence in the Milky Way. One star system, around one ordinary star, inside a galaxy with hundreds of billions more. And the part of that galaxy touched by even the faint possibility of our existence is still tiny enough to be embarrassing. And the annoying part is this. Even after you finally accept the size of a galaxy, the galaxy itself is not the end of the map. A galaxy is not just sitting there alone in the dark. That would be too simple. The Milky Way belongs to a small crowd called the local group, small by cosmic standards, not actually small. It contains more than 50 galaxies spread across roughly 10 million light-years. Most of them are dwarf galaxies, a few matter more. The Milky Way, Andromeda, Triangulum. The rest are the kind of background objects the big ones slowly mess with. So the scale changes again. You are not looking at one galaxy anymore. You are looking at a gravitational neighborhood. Galaxies orbit. They tug on each other, they merge, they fall in. Even here, nothing is really isolated. Then that neighborhood turns out to be part of something larger. The local group sits within the Virgo Supercluster, a structure about 110 million light-years across, or 33 megaparsecs if you want the cleaner unit astronomers use when the numbers start getting stupid. Now the meaning changes. A group is not just a pile of galaxies, it is one piece inside a much wider pattern. Clusters, groups, filaments, empty regions in between. Matter is not spread evenly. It gathers where gravity has had time to do its usual work, and Virgo is still not the last frame. Beyond that is Laniakea, more than 500 million light-years across, not just another bigger label. This is the point where the map starts being about flow, not just location. Galaxies and galaxy groups are moving within a larger gravitational basin. That is why the Great Attractor sometimes gets mentioned, not because it is some dramatic cosmic throne, just because motion on these scales still has structure. Things fall toward denser regions. So the nesting goes like this: stars inside galaxies, galaxies inside groups, groups inside superclusters, and superclusters inside even larger gravitational contexts. Each step removes the idea that anything is standing alone. Laniakea is the last big step that still feels like a named structure instead of the whole observable mess. After that, the obvious question gets worse. If the universe is 13.8 billion years old, why is the part we can observe vastly larger than 13.8 billion light-years? And this is where people usually lose the thread. The observable universe. Its diameter is about 93 billion light-years, not 13.8 billion, 93. Which looks wrong at first. The universe is about 13.8 billion years old, so the lazy math says light had 13.8 billion years to travel. Fine. Then why isn't the limit 13.8 billion light-years? Or maybe 27.6 across? Why is it so much bigger? Because that simple math assumes space sits still. It doesn't. It never did. After the Big Bang, space expanded. Not matter flying into empty room. The room itself stretching. So the light we detect today started its trip from regions that were much closer when the trip began. While that light was traveling, the space between us and that source kept expanding. So now those regions are much farther away than a basic light times time guess would allow. That is the whole trick. Not a trick, really, just reality refusing to be simple. And yes, on large enough scales, some places are receding from us faster than light. That does not break relativity. Because they are not moving through space past light speed in the usual sense, space itself is expanding. Different problem, same bad news. So when people say the universe is 93 billion light-years across, they usually mean the observable universe, the part from which light has had time to reach us since the universe became transparent enough for light to travel freely. That is not the whole universe, just the part we can, in principle, see. Everything beyond that line is outside our view. Not because our telescopes are embarrassing, because light from there has not reached us. Maybe it never will. That matters, because this is where distance stops being a travel problem and becomes a knowledge problem. The observable universe is not the universe. It is our visible slice, our access limit, our information border. The full universe could be much larger, absurdly larger. It could even be infinite. We do not know. And this is one of those rare cases where we do not know is not a temporary inconvenience. It may be built into the setup. That's the real ending here. As the scale grows, things do not just become harder to reach, they stop being reachable in a deeper sense. Then they stop being observable. Then they stop being knowable by direct evidence at all. So the ladder ends like this. First, you can't go there. Then, you can't signal there. Then you can't even see there. And after that, whatever is still out there is no longer part of your world in any practical sense. Maybe not even in any testable sense. That's the size problem, stripped down. The universe does not just beat your ability to travel. At some scale, it beats your ability to know.